Well, hello and welcome back to day 2 of my course, Learn SSJS for Salesforce Marketing Cloud. I'm glad you could make it, and it's good to see all of you here today. So hopefully I don't need to reintroduce myself, so let's get into this. So in our last session, I provided an overview of server-side JavaScript, and we covered JavaScript fundamentals. In today's session, I'll be progressing past those fundamentals, and we'll put our theory into practice, as I'll be spending the majority of our time on focusing on common SSJS use cases. But before we do, I just wanted to cover an additional use case for loops. So you may recall yesterday we discussed the for loop. Now, to recap, I explained that loops provide a quick and easy way to do something repeatedly. In summary, they enable you to iterate over code. And we looked at this for loop, which comprises of our initializing expression, a condition expression, increment expression, and a statement, and follows the syntax here, where we've got our initializing expression, there's the condition statement, and the increment expression. And finally, the statement and the increment expression. Now, today, I just briefly want to cover an additional loop, as we're going to be covering this in one of the examples that we'll be looking at a bit later, and that's the while loop. So the while loop simply creates a loop that executes a specified statement as long as the test condition evaluates to true. It's a lot simpler than the for loop. And the condition is always evaluated before executing the statement. So if we take a look at some example here, so in this example, the condition checks our I variable, and I've gone and set the variable I as 1. And as long as it's less than 10, it will continue execute the code within the block. So in this case, again, I'm using this core function called write we looked at yesterday, and it will write out the variable in the string. Let's say the number is 1. And additionally, it uses this increment operator to increase that, that variable value by 1. And so changing it to 2. So the next time the loop continues, it will 2 is less than 10, and the pattern will continue. All right, the number is 2, then the number is 3, right up until the number is 9. So now I've completed discussing loops, and hopefully you understand JavaScript fundamentals now. Let's progress onto server-side JavaScript. So server-side JavaScript is based on ECMAScript. ECMAScript is a scripting language that forms the basis of JavaScript and is standardized by ECMA International. The intent of this standard is to ensure the interoperability of web pages across different web browsers. And so while ECMAScript is commonly used for client-side scripting on the internet, it's increasingly being used for writing server-side applications and services using languages like Node.js. And in fact, SSJS is in Marketing Cloud is just another example of that. It's important to also to note that SSJS in Marketing Cloud is based on ECMAScript edition 3, which was actually released back in 1999. So fast forward to today, ECMAScript is now in its 12th edition. So while you can't take full advantage of all the JavaScript features in later editions, like, things like asynchronous programming and various functions, which enable you to easily manipulate objects, ECMAScript 3 does provide elementary support, I'd say, for the vast majority of platform use cases. And additionally, look, in fairness, ECMAScript 3 is a lot easier to learn than programming concepts that are introduced in later JavaScript versions. So SSJS features can be broadly categorized into a few different areas. We have core functions, platform functions, API functions, which are a set of functions to access the Marketing Cloud SOAP API. And that's actually identical to AMScript, if you ever use the API functions in AMScript. Then we have the WSProxy object, which provides an alternative to using API functions. And finally, we have script utility objects. In today's section, we'll be focusing on core functions and platform functions, and also WSProxy. I won't cover API functions, as these are effectively now replaced by WSProxy. Additionally, script utility objects, with actually the exception of WSProxy, which is a script utility, but these provide advanced support for external HTTP integrations, and there really aren't that many use cases for them. In fact, I think I've maybe used them twice in the past 8 years. But if you want to learn more about using script utility objects, there's good documentation and code examples available in the community. So let's start by explaining the required syntax for SSJS. SSJS is contained within HTML script tags that has an additional run@server attribute. Now, this attribute is really important as it provides an instruction for the platform to execute the server-side code within it. Note that the server attribute can also optionally be enclosed in quotation marks. I mean, it's just really personal preference. So let's move on and discuss core functions. Before I do, let's discuss functions. So in programming, a function is a named section of a program that takes some input values to perform a specific task and produce an output value. Now, I assume most of you have used Excel before. Excel has also uses functions, things like sum and count and average, where values are passed to the functions as arguments contained in parentheses. And JavaScript and server-side JavaScript actually isn't too dissimilar from Excel in that respect. SSJS includes over 300 functions that enable interoperability with platform features. So let's start by looking at and explaining core functions. Core functions are really orientated around using the Marketing Cloud SOAP API to perform common use cases. They're extremely lightweight, and by that I mean that you can achieve a result often with just a couple of lines of code. And this makes them really ideal for rapid development. However, one consideration is that they're not as performant as platform functions or WSProxy, as they incur an additional overhead as the interpreter has to translate between the different runtime environments. But they're still really well suited where speed may not be a factor, like in a script activity, for example. You're not waiting for a web page to load, and milliseconds really isn't an issue. Additionally, while the functions are essentially a wrapper for the SOAP API, you can't access all the API object properties, only predefined ones for pre-built use cases. Just another comment as well is that they can be quite hard to debug as they eat any meaningful errors and suppress them. So in order to use the core functions, you first need to initialize the core function library. And you can do that by using the following syntax, where we're using platform.load and then passing a couple of parameters across to this load method here, where we would specify core and then the version number. Note that there are several version numbers in SSJS, but loading using version 1 will always load the latest version 1 library. So in this case, it's version 1.1.5. So I'd encourage you just to go and use 1. I mean, there's no real use case for specifying a different version. Now let's talk about platform functions. Platform functions provide a library which is comparable to AMScript, but it's JavaScript based. And unlike the core library that we just discussed, you don't need to load the platform library, as it's actually included by default. Now, platform functions exist outside of the core library and are generally more performant. They can be used in messages and landing pages and also script activities. So these functions can be identified by their naming convention, which comprises of the following pattern. So firstly, we have the object name, which is platform. Then we have the object property, which is one of the following, either application, request, response, variable, recipient, or function, depending on its purpose. And finally, the method, which is effectively our function name. So let's go and take a look at an example. So here's an example of a platform function that uses, similar to AmpScript, the now method to return the current system date and time. Now let me briefly explain WSProxy, which is a relatively new addition to SSJS, as this object was only added a few years ago, actually in 2018. So as this name may imply to you, it acts as a proxy between the Marketing Cloud SOAP web service used by the SOAP API and SSJS. And this object is available in all non-send contexts and has the same restrictions in place as other SOAP API access methods. Now, for example, we can't go and use it to go and in an email, to go and send an email. WSProxy is specifically designed to address the limitations of the SSJS core library and the programming paradigm of platform API functions. So as I said, the core library really isn't that performant, and it's limited to specific use cases. Platform API functions, similar to AmpScript, are highly verbose, and it follows a procedural programming style. Whereas a WSProxy enables a declarative programming approach, which means that the object simply instructs on what needs to be done rather than instructing how to do it, which is actually a very welcome departure. So WSProxy uses JSON or JavaScript object notation to express the object properties instead of XML. XML is the markup language used by SOAP. Additionally, with WSProxy, we can actually use this object to impersonate other business units, that is MIDs, in your enterprise account, and even users, for example, maybe a specific user based on their permission set. And we'll be using WSProxy in one example use case today. So now let me get into this demo and explain the use cases that we'll be reviewing today. And we'll go from zero to hero. We'll go and fulfill these use cases from start to finish. So in our first use case, we want to go and display an offer or promotion on a cloud page based on the website visitors locale. So in order to achieve this, we're going to use server-side JavaScript to do a couple of things, to go and detect the visitor's IP address. And then we're going to use that IP address to go and look up their country using an external API. And here's an example of what we might want to display on the page. So and you can see I've gone and visited this website, and it's saying we ship to Australia. So let's get into it then. So firstly, I'm going to go and open Cloud Pages. So today I'm going to be using a kind of technique where I'm hosting code locally on my computer that we'll see. When I go and save it, it makes a publicly accessible URL. This method is actually quite common in SSJS and Cloud Page development, as it enables you to go and instantly preview your changes without having to wait for a Cloud Page to republish through the CDN. So you can use this syntax here. I won't go into it. If you want to, if you're not unfamiliar with this syntax, head over to Ivan Razin's blog, that is amscript.xyz or XYZ for our US audience today. You'll see that he's provided examples of how to go and use this development method for Dropbox, for Google Drive, for I think OneDrive and others. So you should go and check that out. So But essentially, it's making a GET request to a publicly accessible URL, which is actually related to a file on my computer. And it's wrapped with this AMP-script treat as content function to force any server-side code that is AMP-script or SSJS to be evaluated. And so let's go and actually go and click on this link here to open the page, and just as hello. So here's the code that I've got. So I've got my opening and closing script tag, and I'm using a platform function. So in this case, using the response property, and write is the method. So I can just change this to hello world, exclamation mark. I'll just go and save this, and I'm just going to go and reload my page here. Wait for that refresh to happen. It's taking some time today. It's odd. What is going on here? There we go. Fantastic. I had to think about it. Okay, so let's get underway with this use case. The first thing we want to do is to retrieve the IP address of our website visitor. And so to do that, I'm going to go and firstly define a variable, and we're going to call this var client IP, for that is what it is. And I'm going to use a platform request function. So that is platform.request is the property. And the function name or the method is client IP. And now let's just go and write out that, that value. So maybe I'll just put client IP. I'll go and save this. And notice that I haven't had to load that, that library, which I have to do in core. I've simply just got 2 lines of code here. If I go back and reload the page, you'll notice that I get an IP address. And this, hopefully this corresponds to what is my IP address. And it is. It's the same IP address here. Okay, so now we've got that IP address, we can go and use the IP address to go and look up the website visitor's country. So to do that, I'm going to use an external API, and I'm just going to go and copy and paste this from a different page, just a bit like a cooking show. Here's one I created earlier. But let me explain this one. So this is going to, this uses a platform function called HTTP GET, which is actually very similar to the AMP-script HTTP GET function. And I'm taking the, going to making GET request to this URL and suffixing it with that client IP that we just set as a variable. So this, it's a free API and it doesn't require any authentication. It's actually very convenient. And let's go and now go and put the result of the response. So I'll just go and type in response there. I'll go and save this. And just to, for sake of completeness, I'll put a semicolon here. Save, and we'll just go back and reload our page. And here you can see the response that's come back from the API, where we've got the country, the city they're in, and other metadata related to that IP address lookup. So yep, that's handy. So, and now we need to go and pass this JSON object, or this JSON string, should I say, and specifically we want to go and extract that that country value from here. So the way that we're going to have to do that is use another platform function called parse JSON. So parse JSON, if any of you have worked with JavaScript, you'll be familiar with JSON.parse. This effectively does the same thing. And the reason that we have to go and use this, and we can't go and get that value directly from that that response, is that response that's come back is actually a string, and we need to convert this to an object that JavaScript can interpret. So we're going to use the var obj I'll set this to platform.function as parse JSON is the method, and we pass the actual string that we want to convert to a JSON object. So in this case, it's response. There we go. And then now we've done that, I can now go and get that country key value pair from that object. So to do that, I'll create a new variable called country, and I'll now go and define it. So firstly, we define the object, and I just call it obj. So that is our variable, and we get the property within that object, which, as we just saw from that string that was printed out, was country. There we go. And let's just check that it's going to work. So I'll just write out country. So hopefully when I reload the page, Australia, fantastic. Okay, so yes, it's gone and passed that, converted the string to a JSON object, and then retrieve that country property. You know, in exactly the kind of the same method that we looked at yesterday, didn't we? With that car, how I was getting the model number from the car. It's exactly the same syntax. So now what we want to do is let's go and customize a message. So we're going to conditionally display a message on our page based on whether they're based in, I don't know, Australia or United States. So to do this, I'm going to do two things. Firstly, I'm going to go and define a variable, a new variable called ship. And I'm going to go and declare this as a string, an empty string here. So this will instruct the interpreter of what this variable should contain. I'm going to go and modify this variable, but we initially declare it to describe whether it's, you know, a string or an object or an array or Boolean character. And now I'm going to go and write a simple if statement. So we're going to say if the country is equal to Australia, or do you remember the or operator? That's the two pipes. A country is equal to maybe United States. Then we want to go and execute the following block of code. So I'll just go and maybe put, so I'll go and set this ship variable. So we can go and reset, we can go and change a variable after it's been declared. So I'll say ship is equal to, I'm just going to go and copy and paste this just to keep the session flowing. Then, but otherwise, if the country isn't equal to Australia or the US, we just want to go and put a different message, and that is maybe we don't ship to your country. Now, let's say that we've got this variable, which is great, but we actually want to go and output this on our web page, and we're not going to use this write method. I mean, this is just typically used for debugging. Instead, we want to go and set this SSJS variable as an AMP-script variable. So, you know, this is a very common pattern that you use AMP-script for that presentation layer, and yet we're using SSJS for as effectively our controller. So there is interoperability between SSJS and AMP-script, and that's made use by the provision of two functions, which are set value and get value. So we're going to go and use the set value platform function. So platform is obviously the object. The property is actually variable, and set value. And we define firstly the AMP-script variable. So in this case, it's ship. Note that we don't need to use the @ symbol prefix, but you can. It really doesn't matter. And now we go and define what value we want to set it to. So in this case, it's our ship variable in SSJS. So now I've done that, I can simply go and use some AMP to output that string on the page. So let's go and use the v function to output a variable value, and that's ship. And I'll put a closing delimiter pattern in my inline AMP script here. I'll just go and save this. Let's go and reload this page. And this is, oh, fantastic, we ship to Australia. There we go. So you can see just really in a few lines of code, we've created, I think, a pretty sophisticated use case here where we're detecting that client IP address of a website visitor, then we're making a call to an external API to go and look up the country of that visitor and conditionally display a message back on our page. Now let's progress on to another use case that we're going to be focusing on for the remainder of today. And that is, we want to make a backup of a data extension, which will be included in the script activity and will run daily. So as you probably know, in Marketing Cloud, there's no way, at least through the interface, to copy a data extension. That is the data extension, the schema, all the fields and its records. Additionally, and this is a kind of a problem in Marketing Cloud, is that you can't undo a data operation. So perhaps you accidentally delete the data. I pressed that clear button. Oops, I didn't mean to do that. Or you overwrite some data using a query. So in these scenarios, you can't easily go and restore that data extension back to its previous state. So we want to create a script that creates a temporary backup data extension every few hours. And we're going to do this by performing the following operations. So firstly, we're going to identify a source data extension, retrieve the fields from it. Then we're going to go and create a new data extension. And then we're going to, which goes and uses the fields from that source data extension. Then we go and retrieve all of the records from that source data extension and add those records to our new data extension. And I'll show you how to do this today using both core functions and also WSProxy. Well, let's get into it. So I'm just going to go back to my code and we can clear all this. And of course, I mentioned we're going to be using core functions. So the first thing we need to do is load that core function library. So you might remember the syntax is platform.load, and then we specify core as a library, and we're going to use version 1. And next, I'm going to go and define the data extension name and the key that we're going to be using as our source. I've actually renamed the data extension to use both the same value for the key and the name. And that's because depending on which function that you're using in server-side JavaScript, some require the name of the data extension, others require the external key. And I just find it's better to keep them both the same. So it's more kind of a repurposable. So I'm just going to go and name source DE name key. And it's actually called custom orders. In fact, let me just go and show you it. So we go into here, you can see there's my data extension with 10,000 records called custom orders and has the following fields. There we go. So now that we've done this, we firstly need to go and initialize that data extension with our core library. So the way we do that is firstly define a variable, source DE, and I'm going to use data extension .init, and we're going to pass the external key of that data extension. So now I've initialized it, I can now go and retrieve the fields within it. And let me show you the documentation so we can kind of follow along, because without documentation, you can't write code. So in this case, yes, I'm using this fields retrieve core function. So you can see that I've initialized the data extension. And now I've just got one line of code here that I need to do to retrieve the fields within it. So following that pattern here, I'll just go and create a new variable called var source fields. And it's the object name is the source DE. And we're going to, the property is called fields. And then we're going to use the retrieve method, which doesn't require any arguments. I think you can go and optionally add filter on it. And so now I want to go and output this. So to do that, I'm just going to use the write function, which is actually identical to the platform write function that we used before, but this is just the core version. There are actually many functions that are available in core and platform that effectively do the same thing. Write being one of them. And so I want to go and write out the source fields. But because this is actually going to return a JSON object, I can't display that JSON object on the page. So I'm going to have to use another function called stringify to go and convert that JavaScript object to a string. And we're going to stringify source fields. So now if I go and reload the page, hopefully. Fantastic. So we see we have an array here of different objects. And in each object, we've got key value pairs of all the metadata associated with a field. So there's obviously one field with a name order priority. There's text. It's a maximum length of 1. And the next one is region. And you can see whether it's a primary key or not. So that's great. We're going to go in. Now that we've got these fields, we can go and use this to create a new data extension. So let me go and show you how we're going to do that. So this data extension function add here, here we go and define firstly an object, and then we go and use this add method to go and create a data extension based on that object that's been defined. So we just really need 3 different properties in this object. So we got the external key, the data extension name, and the fields. So let's go and build that out. So the next, what we're going to do is actually, before we're going to do that, I need to go and modify this field array slightly. That is, we can't simply go and take the fields that we retrieve from the data extension and go and use this array to go and create a data extension, because notice that each has an object ID. So this is, it's like a kind of external key at a field level. So this is unique. So we can't just go and copy this. So what I'm going to do is going to go and create a new empty array, and then we're going to loop through all of the objects that we just saw in that array and add them to this empty array that we've created. So I'm going to call this one var field array, and then we're going to, I think for in sake of time, I'm just going to go and copy and paste this code here and explain what it does. So we're actually going to create a for loop. So where the we're setting the initialization variable to 0, and then we're comparing this. It's less than the length of source field. So this is based on, this is going to go and count the number of objects in that source fields array. In this case, I think it was 8 or something like that. And then if for each field, it's going to execute this code within it. The first thing we're doing is to going and creating an empty object called field. And then we're going to go and add and name value pairs to that object. And the way that you do that in JavaScript is simply we go and define the object name, so that is field, that empty object I've created, and then the key that we want to create in the object. In this case, it's name, and here we go and put the value that we want to use. So in this case, we're using source fields as the object, And then this is remember the index number. So when you're working with arrays, obviously because arrays are zero-based and sorry, indexes are zero-based, we can simply go and use this, I guess the counter variable in our for loop to go and get the name for the corresponding object from the loop. And we repeat this pattern for other fields we want to include in this object. So in this case, we've got field type, and we've got a couple of others down here. So this one here is that if for text fields and only text fields, we want to include this max length key value pair to define the maximum length. So you notice that I've got an if statement here to say that, if the field type is text, and let me just show you here. So for example, it's saying, oh, the field type of this first object in the array is text, then it's going to execute this code within it. So in this case, it's going to go and set the max length to based on the value of that maximum length. The reason we have to do this is I've observed that you can, if you go and set it for like date and max length is 0, I think you can just become problematic. And so we do exactly the same thing for primary key. So if there's a primary key, then we need to ensure that it's a required field. So I go and add that object to, so I add this name value pair to our object. So the final statement here is we're going in using the JavaScript push method to go and push that new field that we just created into that field array that we've, oh, sorry, the var field array is actually an array. There we go. So let's go and take a look at what that looks like. I'm just going to go and write that out. So write, and then obviously because this is an array, we need to go and convert it to a string first. Stringify, and then field array. And we'll just go back and reload the page. In fact, I'll just go and delete this one or comment out this one here, to prevent confusion. And fantastic. So here we have, so it's iterated through all of the fields that we've retrieved, and we've kind of programmatically created this new array with just these core name value pairs that we want to use to go and create our data extension. So now that we've done that, we can go ahead and create a data extension. So firstly, we need to go and define a unique value to use as the customer key and the data extension name, because obviously if we're going to be creating this data extension every few hours, it's we need to name it something different each time. So to do that, I'm going to just simply use the GUID function. Again, there's this, if you've used AmpScript, then you'll be familiar with, there's a GUID function there. This is exactly the same thing, and it's a platform function. Platform.function, and it's called GUID. Surprise, surprise. And so this will go and get a 36 character GUID value. And now we can go and use this as maybe our external key, and maybe you want to go and prefix the data extension name that we're, suffix the data extension name that we're creating with this unique value. So I'm just going to go and paste this code in here and explain what this does here. So firstly, we define the name of our data extension. So I'm basing this off the name of our source data extension, but then appending it with an underscore character and then that GUID value that we just created. And I'm also just using that GUID value to go and create the, or to set that external key for the data extension. So this object here, we go and have a look at the documentation and show you what we're doing here. So there's my customer key, and I've got the name. My name is that that name I just built programmatically. And then I've got the fields, and the fields here will be the array of fields that we just created. And then additionally, I've added an additional a key value pair here of category ID. So this actually corresponds to the folder where I want my data extension to be created. So to obtain that, probably the easiest method is if you just hover over the folder name. You'll see if you've got a good eyesight down the bottom left-hand corner, you've got category ID of 6808. That's kind of the easiest way to get it through the interface. So we'll save it to this folder. Without it, it will just save it to the root level data extension. Now to create that data extension, I've already all I have to do is to use this core function of data extension dot add. And then we go and pass through the configuration that we've for that data extension that we define in the object. So just by doing that, I'll just go and save this and go back and reload my page. And hopefully if I revisit this, yes, it's fantastic. It's created a data extension with exactly the same schema. Well, that's exciting. So we're almost there. All we need to do now is to go and retrieve the records from that source data extension and add them to this new data extension we've created. And as I mentioned before, that core functions are really facilitated rapid development, and this is a great example. So in order to go and retrieve the data, I'm just going to go and create a new variable called data, and I'm just going to go and set it to the source data extension, source DE, which we initialized above, didn't we? Source DE, there we did, yeah, we initialized it earlier when we went and retrieved the field, so we can reuse that. And then I'm using rows dot retrieve to retrieve all of the rows or records effectively in our data extension. So I'll show you rows and retrieve. This is exactly what we're doing here. Additionally, we can go and filter out specific rows, but in our case, we want to retrieve all of them. So we won't include any parameters here. And then if this works, we should just be able to go and see all of those rows in the data extension. So I'll just go and write that out on the page. Save, and then we'll go and reload our page. And there it goes. So we've got all of those rows from the data extension, or is it? Well, I'll answer that question just in a moment. So now that we've retrieved those rows, we need to go and add them to our target data extension. So we don't need to write them out anymore. So to do that, we're going to go and define a new variable that's var target DE. And I'm going to go and initialize this one. So I'll just go and do that by doing data extension dot init dot and then GUID. So this is the external key of the data extension that we just created. And now we can go and add rows to them, and we can simply do this by using the rows add method. So which goes and returns the number of rows inserted. So if I just go and say var count is equal to target DE dot rows dot add, and then we're going to add the data that we just stored. And I'm just going to go and write some code so we can see that it's actually worked. I'll say write insert and then the value of count, which hopefully should be the number of rows inserted into this data extension name that we defined up the top here, a DE name there. So we're just going to save this. When I reload the page, again, it just takes a few seconds to run. Got a few operations to go and perform. And while it's doing, if we just go back to this folder here, hopefully we can see, oh, it's gone and created a data extension. And look, it's already 409, 972. So you can see that those records are being inserted as I go and reload this folder. You can see that here they are. And it stops at 2500. And that's because, like I said, these core functions are just really kind of a limited use cases, including it will only retrieve the first 2500 records. And that's because the SOAP API retrieves records in batches. It goes and gets a batch of the first 2500 records, then the next, and then the next. With the core functions, you can only get up to 2500 records. Obviously with AmpScript, you may recall that it's 2000 records. So anyway, we need to get all 10,000 records. So in order to do that, we need to use a different approach. And to do that, we're going to use WSProxy. So there are quite a few lines of code involved, and I won't be writing out all of this code here, but I'm just going to go and paste this in here and explain what it does. So the code that we see here is actually identical, in part identical to the code that we just created in this previous example, in that I'm using exactly the same approach to go and retrieve the fields, to go and create this array of the fields that I want to go and add. Additionally, I've gone and added some additional properties. When we go and add that data extension, I'm adding a data retention policy to it by setting these attributes here, these 5 ones here. On a side note, this is only achievable really in a script activity. That is, if I was to go and use this in a on a cloud page, I think it will only work if the user's role who created that cloud page is a data manager role. Anyway, we're going to be using this in the script activity, so that's fine. So everything else is the same. I just went and added those 5 fields there. And now we can get on to our use of WSProxy. So to go and use WSProxy, we have to firstly load or initialize it. And the way that we do that is by defining a variable and using this syntax here of new script utility, and then the method is WSProxy. And so once we've done that, then we can now go and use it to retrieve or update or perform actions. So I'm going to skip past this. Let's come back to that later and have a look at this code here. You can see I've just got like maybe a dozen line of code, and this is really kind of the kind of where the heavy lifting is happening. So let me talk through this line by line. So firstly, it's saying while more data. So while more data is true, then it's going to execute the code within it. So as you can see, I've already gone and set a variable called more data to true. So the first time it runs is obviously run. And then as soon as it does, it changes it to false. So unless this is changed back, then it won't run again. So now it's saying if the request ID is null, and again, I set this request ID variable to be null. So in this first instance, it's going to execute this line here. So you can learn more about WSProxy methods in Salesforce help, but this goes and I'm passing 2 arguments as parameters. So firstly is the SOAP object that we want to execute. In this case, it's a data extension, and with the external key of the data extension, and also the field names that we want to retrieve, and that's that field name array that we created earlier. What else do we have here? So if the request ID is not null, which I'll talk about in a moment, then it's going to use this alternative method here to go and get the next batch of 2,500 records. So what I'm actually doing is, as part of this while loop, I go and get a request. I go and get the request ID. So if there is more data available, then there'll be a request ID, and I can use that request ID to go and get the next batch. So that's what that's doing there. So the request ID. So the next time it runs, the request ID would not be null, and it will just go and get the next batch based on that. So now that I've actually gone and got that data, I need to just apply a little kind of minor transformation because there's some additional properties that are included in that data that I'm getting back through WSProxy that we need to change before creating records. And so that is, you can see I've got customer key and and some partner properties here. So the way I'm transforming this data is by using a JavaScript function called replace. And you've got a regular expression pattern here. And what this does is it will go and globally find these key value pairs and replace it with something else. So it's just a kind of a really quick and simple way of globally making a change, and in this case 2,500 records without going through record by record. So we can perform this just in a matter of like a couple of seconds rather than 2 minutes that it would take to loop through the records. And then but in order to convert it, I've actually, firstly, in order to apply that find replace on it, I have to convert it to a string, and then once I've done that, I convert it back to an object. And so once we've done that, we can then go and then use this other WSProxy method to go and take that batch of 2,500 records and insert it into the data extension that we created, which is what this line does here. Now, I'll be providing you this code and the other code examples that I've shared, along with a copy of the slides later this week. So keep a lookout for that in your email. But for now, let's go to Automation Studio, and there's the, I've created an automation with a simple script activity. So like I said, that we're going to go and create this every, so we create a schedule list to run, say, every 3 hours or whatever cadence that we want, where we want to back up that data extension. And I don't know why Automation Studio isn't loading. So let me just go and refresh it. So we'll kick that off. And it's going to take a couple of minutes to run, but while it's running, I thought that we'll just open the floor for questions. So there it is, and I'm just going to click Run All Activities. Run once, click Run. So there's the single script activity, and hopefully it's running. I'll click Refresh. Okay, well, let's hope it will hopefully kick off in the next minute or so. So while we're waiting that to finish, and I can show you that the data extension that it creates, and we'll just check it has 10,000 records in, I can see there are a lot of comments here. So let me start covering some of those off. So yes, Yash asks, how are the changes in Sublime reflecting on Cloud Pages? I'm confused. Yes, I don't blame you. So maybe you joined a bit late, but as I explained, I'm using a kind of technique where, in this case, it's Dropbox on this computer, but you can use Google Drive or any file sharing solution which creates a publicly accessible URL. So when I go and save this to my local computer, it's synchronizing with Dropbox, and then I've gone and put that Dropbox URL on my cloud page here. To learn more about this technique, I mentioned this earlier, but .xyz. I head over to Ivan Razin's blog, and he explains all the procedural steps of how to do this. You can just search for Dropbox, and this will take you through to this blog post here he published last year, and shows you how to do it for all these other different platforms. So go and check that out. So next question. We have, yes, oh, thanks, Aaron, you answered that. Yeah, oh, good, and Aaron provided the link, even better. Will I provide the sample code? Yes, absolutely. As I explained, I'll be supplying that sample code. Any other questions? Feel free to either post into the chat or maybe the Q&A app, which is in the tray of your Zoom application. While you're thinking about questions, let's just check in our automation, and oh, it's running now. So if we go back to our email studio, click on SSJS, hopefully we'll see, there it is. So we've got a new data extension that's been created, and it's already got 7,500 records in. As I'm going and clicking refresh, you can see that it's already incrementing. So Daniel asked, when you initialize the new data extension, I used a GUID is the name of the data extension. Why not use the new name DE name variable? So no, I initialize it using the external key. So hang on, 944 and 10,000. So you can see it's just created this duplicate data extension in here with all of the records, and it would just continue looping through. If you had 100,000, it would pick all of those up too. So let's go and have a look at that code to answer that question. So when I initialize that new data extension is, here we go. So target DE, why did I? In fact, why did I even go and initialize that data extension? Target data extension, initialize GUID. Was this from my previous code? Find. I don't think this is, maybe that's from the previous example because we don't need this anymore. But let me just jump back to that previous example so we can have a look at in context. Did I? Oh, yes, I did there. Yeah, that makes sense. So you can see you initialize it using the external key. In this case, I've used just a GUID value, but you're right. I mean, I could have used the both the data extension name and GUID value, just like I've done for the data extension name. However, I did read earlier this week in the SSJS documentation that they had recommend using external keys of 36 characters for kind of performance issues. I'm not quite sure what the performance implications are, but yeah, really for simplicity, I just use that GUID value because it was unique. Gotcha, thank you, no problem. So let's have a look at Q&A panel. Debugging internal 500 error tips. Yeah, fantastic, great question, Laura. And we're kind of out of time, but I really want to cover this. So let's just say that you get that dreaded 500 error, because for security purposes or reasons, Marketing Cloud suppresses any errors that return on the page. So in order to debug it, and let's just say that I'm getting an error when retrieving records here, I can add a JavaScript try catch statement around this. So you simply go and write try, and then I go and say catch, and then I define a variable of, let's say E to represent the exception, and then I want to go and write out that exception. So I'm going to go and write, then I have to write stringify because it actually returns the exception as an object. And so in this case, that if there is an error, rather than throwing a 500 error, it will kind of gracefully return the error message. And depending on what function that you're using, sometimes this is helpful and sometimes it's not. But you'll, when debugging, yeah, particularly, so WSProxy is very declaratively, it gives very helpful messages back. Yeah, you definitely want to go and use that simple JavaScript technique to isolate any offending code. Well, I think they're all the questions. I've answered all of those, and we're out of time. So thank you so much for joining this second session today. I hope you found it helpful. As I said, we'll be going and sharing the slide deck and the code examples, and I encourage you to go and use them in your own projects. So hopefully you'll now be able to get on your path to proficiency in using server-side JavaScript. See you next time.